Yeah, hi guys. Welcome to my YouTube channel. And in this video, we are going to see one of the UGC Net June 2023 cycle question, which is related to the network analysis. Okay. So before going into the main content of this video, I want to announce one of my course, that is the Intern Super 30 UGC Net Electronic Science course. And this course is for the candidates who are preparing for the UGC Net December 2023 cycle, and there is a 100% money back policy is also there. Means whatever the topics I am covering in my course, if those topics are not up to the JRF cutoff score, then the money will be refunded back. And whoever the interested candidates are there, you may express your interest by WhatsApp me to the provide number, that is 8639439984. Okay. And what are the things you are going to get in this course is that 90 plus hours video lectures you are going to get, both paper 1 as well as the paper 2. And the doubt clearing sessions will be there. Topic wise notes also will be provided. PYQs and the MCQs also solved in the video lectures, and the unit wise test series also provided. And the course fee, as I already mentioned here, that is 20,000 rupees is the course fee. And if you guys don't know about me, then there is a small introduction. Myself, I am Ashwani Kumar. So, ever mentor YouTuber as well as an academy, ex educator of UGC Electronic Science as well as a general paper 1. So, with 14 years of teaching experience as an assistant professor, and qualified the GATE and UGC Electronic Science for more than twice. And with my course, the lot of candidates are already pursuing or completed their PhD from the Institute of National Importance colleges like IISc, IIT, NIT, central universities, and the state universities. So if you guys interested, then you may take the subscription plan. Okay, fine. So now, as I already told you that in this lecture, we're going to see one question related to UGC Net June 2023, previous year question. So I hope that my audio and video, everything is fine, right? Okay. So have a focus on this question. The diode used in the figure, it is a diode. The diode used in the figure has a threshold voltage of 0.5 volts and a forward resistance of, that means internally it is having the forward resistance. Okay. So if it is the diode, just a minute guys. Yeah. So if it is the diode, then as per the piecewise linear approximation model, this diode can be taken as equivalent circuit in this format, and it is a V gamma, nothing but a cut-in voltage, or else a threshold voltage as I mentioned. So which we can take it as a 0.5 volts. Okay. And it is the forward resistance of the diode. I mean, if the diode is forward biased, then it will be the forward resistance, which is in the range of few ohms, few hundreds of ohms. And if this diode is reverse biased, then it is called as a reverse resistance, so which is in thousands of ohms of resistance will be there. Of course, if you want to get the extension of this one, then you can take the switch also here. So it is the equivalent circuit of the diode, and the switch will be closed whenever the diode is forward biased. The switch will be open whenever this diode is reverse biased. Okay. And as per this question, this V gamma is 0.5 volts and the forward resistance means this RF is equal to 4 ohm. So it is what they mentioned in this question. And they're asking to calculate the current flowing through, that means they're asking to calculate this current ID and the voltage drop across this diode. So voltage drop across this diode means, so what they're asking from here to here, this complete thing they're mentioning as a VD. Okay, and this VD can be given as a, see guys, this VD can be mentioned as this V gamma plus voltage drop across this forward bias resistance. Okay, so V gamma, they already given that it is 0.5 volts plus voltage drop across the resistance means resistance is already given as a 4 ohm. So current flowing through the diode into 4 ohms. Okay, so it will be the VD. So it is all the basic concept what they given. So what generally when you see this type of question, then what we will do is that, okay, let's apply the KVL. Okay, let's apply the KVL and let's start doing the analysis like by writing the KVL equation. This current is entering into the negative terminal, so minus 5 plus 1K into current flowing through the diode plus VD is equal to 0. We will start doing so and so, etc., etc., etc. But one my simple solution what I am trying to tell to solve this type of questions is that carefully try to understand, guys. So here VD is from here to here. That means at this point, how much voltage will be there? At this point, it is having the VD. Am I correct or not? Why? Because from here to here, it is the VD, means at this point, VD is there. Now, whatever the current ID is there, so which is flowing in this direction, as per the KCL analysis. We will discuss about the KVL, KCL, everything in the basic electronics series. As if right now, just try to understand that. I mean, if you take any one branch as like this, if it is a resistance and it is a node A and it is a node B, and if the current is flowing in this direction from node A to node B, and if the voltage at the node A is VA and the voltage at the node B is VB, then the current flowing from node A to B can be taken as a starting voltage minus ending voltage divided by resistance in between both these two. So because if the arrow mark is flowing like this, means it is VA will be the starting voltage and VB will be the ending voltage. In the same way here also, what I can take is that ID can be taken as a, carefully observe this, ID can be taken as a starting voltage is 5. Okay, 5 minus here ending voltage is the VD, right? So I can take 5 minus VD divided by what is the resistance in between both these two? 1 kilo ohm. So all of you understood this expression or not? See guys, in my lecture, if you are having any doubts, then please put that in the comment section your doubts. Okay, fine. So now coming to this one, here VD they already given in this one, right? So VD is given. Let's substitute each and every VD here. So that is, as while coming to the first option, 5 minus VD they given as 0.45 divided by 1K. Then 5 minus 0.45 means how much you are going to get? 4.55 milliamperes. It is the first option. That means if the VD is equal to 0.45, then you got the ID as a 4.55. So here they given as 4.521, which is the wrong option. Okay, let's take the second option. 5 minus, in the second option, what is the VD? 0.48. So 5 minus 0.48 divided by 1K. Then how much you will get? 2, 5. So 4.52 divided by 1K means 4.52 milliamperes. Correct or not? That means if VD is equal to 0.48, then ID is equal to 4.52 milliamperes, which is absolutely wrong. Okay, let's check the third option. Okay, the third option, VD is 0.52, right? So let's take the third option. 5 minus VD is 0.52 divided by 1K. So 5 minus 0.52 means 95, it will be 3, 5, 4, 5, yeah. So I can take 4.48 divided by 1K, which can be taken as milliamperes. So 4.48 milliamperes, 4.48, which is matching. So let's put the third option aside. Okay. Now let's check about the final option, that is the fourth option. In the fourth option, what it is having? VD is 0.62. So 5 minus 0.62 divided by 1K. 5 minus 0.62 means how much we will get? 10 minus 2 is 8 and 3, 6, 7, 8, 9. Yeah, so 4.38 milliamperes. But here 4.32 is there. So you can make it as a wrong one. So finally, what is the correct option here? What is the correct option? We got the correct option as 3, where the values are exactly matching. Yes or no? Okay. So as per this analysis, the third option is perfectly matching with the values. So you have to do like this. Okay, if they're asking the two things in the question, then just try to frame one equation with the help of the two parameters, whatever they're asking the question. Substitute one parameter and check for the another parameter value, just select what I did right now. So it is the first option related one, it is second option related one, and it is a third option related, and it is a fourth option related. Out of all these four options, the third option is perfectly matched to the 4.48 milliamperes. Okay, so it is what you need to do. Okay, otherwise we can apply the KCL analysis also, that's your wish. Okay, okay, so it is what I wanted to tell in this present lecture. So in the daily one video I'm uploading in this YouTube channel. So share this YouTube channel link to all of your friends or colleagues who are preparing for the UGC NET Electronic Science. And once again, I am telling that this channel is not only for the UGC NET Electronic Science candidates who wants to get the basics regarding the electronics and communication. This channel will be really, really, really helpful. Okay. Okay. So before closing this lecture, so once again, I want to introduce regarding this course, as I already told you. So it is the Intense Super 30. Only first 30 candidates are going to be selected. Okay, so 31st candidate also I am not going today. Why? Because if the strength is less, then I can focus more. And the contents we are going to cover in this one are, so theory lectures, the two live online classes. Okay, we can interact very finely. So both paper 1 and paper 2 will be done. Doubt clearing sessions for every 15 classes. Topic wise notes or the PDFs also will be available. PVQs and the MCQ solution also will be there. Video solutions. Unit test test series also will be there. Okay, and it is a myself introduction. So thank you very much for watching this lecture, and tomorrow we will meet with one more topic. Bye guys.